Hello guys, in this video we are gonna solve this problem. If this is n and here n, we will show that if n minus 1 factorial is congruent to minus 1 mod n is equivalent to that n is a prime number. So we will show, first of all we will show this by this way. We will suppose that n is a prime number. It's a prime number. And we are gonna show that n minus 1 factorial is congruent to minus 1 mod n. So we have n minus 1 factorial is equal to n minus 1 multiplied by n minus 2 to n. We have that z over nz is a corp, so that every element of nz over nz is inversible. So here we have n minus 1 to the 2 to the 1, so every element here have an inverse. And if you remark that n minus 1 multiplied by n minus 1 is equal to n square minus 2n plus 1, and that's congruent to 1 mod n. By that we can say that n minus 1 is the inverse of n minus 1, and every element here has an inverse to inverse in this factorial, but n minus 1 doesn't have it, because n minus 1, the inverse of n minus 1 is n minus 1. So here n minus 1 factorial will be congruent to here every product here. For example, n minus 1, we can find a number here to multiply it by n minus 1, and will be congruent to 1 mod n. And n minus 1 will not have an inverse, because n minus 1 is the inverse of itself. So this, all of this n mod n, and this so that's what we need to show. And now we will suppose that n minus 1 is congruent to 1 minus 1 mod n, and we will show that n is a prime number. I will suppose that n is not a prime. So n is not a prime. That will give us that n is equal to d multiplied by b, and d and b are less than n. I will suppose that the product of these I will suppose that D and B are positive, and you can and after that I will suppose that they are negative, but it's the same the same proof. So n minus 1 factorial will be equal to n minus 1 multiplied by n minus 2 and here we can find n minus b, for example, and here n minus d, because d and b are smaller than 1, and here 2 multiplied by 1. So this is will equal to n minus 1, n minus 2, I will bring those two together, n minus b, n minus d, 2 multiplied by 1, and so that will give us n minus 1 factorial will equal to n minus 1, n minus 2, and here will give us n square minus dn minus bn minus or plus db 2 multiplied by 1, and this db is equal to n, so we can factor by n, so n factorial will equal to n minus 1, n minus 2, here like n minus d plus 1 or something, or n minus b minus 1, 2. So this is will be congruent to 0 modulo n, and we suppose that n minus 1 is congruent to minus 1, so that will give us that minus 1 is congruent to 0 mod n, and that will give us 1 is congruent to 0 mod n, and that will give us that 1 is that n divides 1, so n is equal to 1, but that is up, that's that contradiction with that n is actually superior than 2 if it's equal to 1, so that's just one case. And here I actually forgot that n is superior than 2. So by this implication and this application are, when this implication and this implication are true, so if n minus 1 factorial is congruent to minus 1 mod n, that is equivalent that n is a prime number.